An overview of the lesson that I did, students first had salt on top of a cup that was covered with the coffee filter. They had to talk to each other and talk to the cup to see what the salt did when they talked. They made low noises and high noises and recorded what their observations were. We also used diffraction gratings where students looked at the light and described what kind of things the diffraction grating did to the light. Once we did that, we discussed as a group how those things represented waves. Then into that, what we moved into was notes where students looked up on their own what waves were, what the different types were. The part that you see in the video is where we're actually going over those notes as a class discussion. You're going to make a concept map. So for yours, your concept map is going to be about, what did we talk about today? Waves, okay? There are a whole bunch of different ways you can make a concept map. So it's between you and your partner on how you want to do it. But to kind of give you an example, I'm going to do mine on seasons. So this is to give you an example of what it could be, okay? So if we're looking at our map, if I talked about seasons, how many seasons did we have then? 4. So I'm just going to draw little lines going off, talking about fall, talking about spring, talking about winter, talking about summer, okay? Now, so that's the beginning of my concept map. So I've got little lines just coming off the side. Now, if you want to keep going and do more, that would be fine. For example, then, do you know anything else about winter? Winter's cold. So I could put up here that winter would be cold. Does it have long days or short days?
Short days.
Short days. So I could put short days, okay? I could put that it's a solstice. All right, where could I put equinox at then? All right, so where would I put equinox at then?
Spring and fall.
Spring and fall. I could say this is the equinox. Okay? Now, for spring, I could put that it's warm. Okay? All right, I could also put no tilts. Okay? All right, for summer it's hot and it's a solstice. Okay? And then of a wave. So if we're thinking for number 1, Hunter, what did you put as your answer?
Disturbance that moves through matter or space.
All right, good. So a disturbance that moves through matter or space. That filter disturbed stuff and this light bulb disturbed stuff because it was moving through. Okay? Now, when we're talking about space, we're talking about empty space where there's nothing else in there. Where is the only place we're going to go to find empty space? So where's the only place? And now, if we're looking at number 2, you're going to see words called medium and matter. And if we're thinking of medium and matter are the exact same thing. So for number 2, when we're looking at it, waves can carry energy. They don't move matter with them. Now, you know that pretty easily because when you were talking to the salt, did the salt blow off the cup? No. When I looked through the filters and you looked at the light, was any of this air in this room actually moving with the light and hitting us in the face? If we're thinking of matter then for number 3, there's 3 types. One can be a medium. So medium is the same thing as matter. Hold on, we'll get you back, Hunter, okay? 3 examples of a medium are a solid, a liquid, and a gas. But if we're thinking then of you talking to somebody, when you talk to somebody, are you blowing air in their face? You're making the air move, but it's not hitting them in the face, okay? Now, this is what we got to think of. Think about you in your room right now. If you have the radio on too loud, what do your parents tell you to do? Turn it down. Because that sound can travel through a solid. It's going through the walls. So if it's going through the walls, it's way too loud, okay? Think about you if you're underwater in a swimming pool or the lake. If somebody's yelling or somebody talking, can you hear sounds under the water? Yes. Can you hear it perfectly the same, though? No. Sometimes it might be, it depends on how close they are, but a lot of times it sounds different. That's because that sound's going to be changed, but it's going through it, okay? Now, for number 4, these are the 2 words we kind of got to know. For 4, one of the ways we need to know is it's going to cause something to move back and forth. So when it gives something energy, in order for that wave to be made, it's got to make something move back and forth. That's what that disturbance is. So in order for me to make it have energy, something in there's got to be changed. Okay? So you might want to put beside number 5 the word sound because that's going to be an example of it. So sound is a mechanical wave. Now, if we go back then and we look at number 6, the type of wave that doesn't have to have anything to go through it is going to be electromagnetic. So if we look at 6, the type of wave then that doesn't need anything is electromagnetic. Now, when we're talking about it, if it's electromagnetic, an example of that then would be light. So beside number 6, you want to write down light. Now we got to go back and look at actually how they move. So the next two we got to look at is compressional and transverse. Okay. So I started with transverse for number 7. So if you're looking at number 7, it told you first to write a definition down. So I'm going to give you the chance to make sure that you're looking and see if your definition is the same as the book. So a transverse wave is going to cause matter to move back and forth at right angles to the direction the wave travels. Now, if you're like me, that's a lot of words and that's not making a lot of sense. So Hunter, we're going to let you come up here and be our little model for a second. Hunter's just going to hold the slinky still. So right now, does this slinky have any energy in it?
Yes.
All right, we're going to pretend it's not moving though, okay? Now, if it has no energy, I'm going to give it energy by making it move up and down. Did it stop when it left my hand though?
Nope.
No. Did it stop when it hit Hunter? No. It traveled back and forth. But is the slinky actually hitting Hunter in the face though? No. How's the slinky actually moving then? Just up and down. So what we need to do, everybody give Hunter a hand. He was a beautiful model today. He can give you a bow. There we go. If we're looking at what we got, in the beginning, it started with no energy. So it was at rest right here, okay? Now, once we gave it energy, though, how did it move? Up and down. So right now, we want to draw that slinky moving up and down. Now, it says it moves it back and forth at right angles. So let's think of the energy. Which way did the energy actually move? Back and forth. So you want to draw a little spot that says energy and show that it moves back and forth. Okay? Now, what happened to the medium or the slinky? How did the slinky move? Up and down. So if we draw the arrows this way, what kind of angle is that showing then? Right angle. So basically, that's what it's showing when it's a right angle. Okay? Now, the type of seismic wave this would be a secondary wave. Okay? So that, you might want to put beside it. That's going to be similar to that secondary wave. Okay? All right, Ty, we're going to let you come up here for our last one. He's going to be our next model. For B, what we got to look at for B is then we had transverse. B should then be what kind of wave? Compressional. So if we look at compressional, here's what we should have as our definition. It causes the matter to move back and forth along the same direction in which the wave travels. Again, a lot of fancy words. But Ty's going to hold that. He's going to look real pretty. It's going to be totally still. So right now, does it have energy at all? No. If I let the coils go, though, does it have energy? Yes. Is it hitting Ty or me in the face? No. How is the slinky moving then? Back and forth. So it's moving back and forth. If we could freeze it and make it look bigger, it would be squished together, pulled apart. Okay? We got to decide. Here's our slinky. Now, which way did the energy go in this one? Back and forth. So energy moved back and forth. Which way did the slinky move in this one?
On like.
All right, so did it go a different direction or the same? So how did it move then? Different direction or same? Same. So energy and the slinky both moved then back and forth, okay? So this wave is compressional. In other words, it's squishing it together, pulling it apart. What type of wave should this one be? If it's a seismic wave, should be a primary wave. Some of the reasons I chose for doing this strategy was since it was a pretty wide range of 2 different types of waves where they had mechanical and electromagnetic, compressional and transverse, I thought this would be a good way for students to be able to put everything we talked about in one class back to one main unit or one main topic, which was waves. What I want you to do right now with your partner then, and if you need to, push your desk together. What's your topic going to be though? Waves. So in the middle, you want to write down waves. You can think of anything that we've talked about today. For my evidence that students understood the lesson was, were they able to actually fill the concept map in on their own with giving good ideas of what those waves were, what were their parts, could they branch off of that concept map? Yeah, that'd be perfect. So compressional coming off one side, transverse coming off the other side, okay? Yeah, you could say electromagnetic's a choice.
What about ultraviolet?
Okay. Is that a wave? Yeah. So you could put ultraviolet. All right, draw your little line saying it goes off. So sound would be one. Volume would be an example. Vibration would be an example.
What about radio?
All right, where would radio go? Yeah, you can have an example. The thing I like most about using the concept map strategy is that students are able to show me what they actually learned without me actually telling them what to fill in. So I'm able to see what kind of things they got, what their minds do to put different things together. My main advice to math and science teachers, if they use a concept map, is to make sure that they pick a topic that has more than one main idea and that has lots of supporting details so they can make a full and complete concept map.